Alright, welcome back. In this video we are going to work on strings. So strings are going to be a special type of value where the data itself is not directly inside the object, it's not on the stack, it's instead on the heap. So it will be a part of a general class of things called objects, which means that in here, in our value thing, we're going to need a new type of thing, which is just called an object. So we need to define this object similar to how we defined nil. So it's going to be a struct, and it's going to have something inside it. Let's leave it empty for now. So as this object type will need to support multiple different things like strings and classes and instances and whatever, we're actually gonna make it a union type as well. So in the book they're using C, but since we're using Odin, we will do something slightly different than what they're doing in the book. And the first type of thing we want is probably a string. Let me disable Copilot so we're not distracted by that, and yeah, that's it. So here the string object has an object inside it, which is to do type punning, so-called type punning. But we don't need that because we have this support for unions, so I think we don't need that. Now it also has a length and an array of characters, so actually this we don't need this, and this is just the Odin string. So I think we can even just do like this and use the built-in string type of Odin. Okay, so now that we have that, we should add support for parsing and compiling and all that, because what's it saying? And a union with no nil must have at least two variants. So let's get rid. Well, let us. That's a bit annoying. Okay, but for now let's not have the no nil requirement. So we don't really support strings. So that's what we need to do now. Go on the compiler, we go in here, and here where string is handled in the parsing rules, we need a function. So I don't really want to use the same number, so let's call it parse string, and the precedence is still none. Let me see again. Here, okay. So let's make this function, aka procedure, and here I suppose, do we have this emit constant? We do. So let's emit a constant, but first we need to make a value, so something to put in there. And how do we do that? I suppose the token, let's call it the string token, that should be the previous of the parser, and then we should make an instance of this guy. So let's call it value, and it needs to be, do it like this, and it has to be an object. Well, I suppose the string, what is the token type? What is not that, but what is the thing returned by this guy? It's a token, and what is a token? It is this thing. So we need the lexi, which is already a string, and then we should be able to just emit that constant value. probably won't work, but let's give it a try. Okay, so that doesn't work. So I've kind of forgotten how to make a value. Don't we have something that's like make a value? We actually have in, what did I do? We actually have in here in the VM, in the value function, we have these guys. Right. So if we go back to pass string, we can even call it the compile string. Let's call it compile string instead, because that's kind of what we're doing. So so here we have the string. Now we need to, so that's the string. I suppose we can cast it as an object, and here let's, for now, let's do this, and like so. Where's it? I think we need. Okay, so this guy is now of a type of object. So can we cast it again to a value? Will it understand that? So it does understand that. And here it's just nil, which is what you would expect. So let's put in the value. Let's run it again, and let's do this. And now we can load strings. So I suppose he does something where he omits the quotes. So I suppose we should do that as well, but I'm not sure how to do that. So let me see here in the Odin documentation. We need to take like a slice, and what happens if we do like this? Probably that's not how you do it in Odin. Yeah. Like that. Aha, so we cannot do it here because this is a value. Okay, makes sense. But maybe we can do it here. So let's do this. And index cannot be negative, so it's not like Python. Let's get the lexeme out as a separate variable. And do this. And then we'll say length of legs -1. And now let's try to do this. And now the value is just 1, 2, 3. But of course we cannot really see that it's a string anymore. But I think that's fine. Maybe we want to do something in the disassembler. So here, if it's a constant, let's try to also print the type. Actually, let me wait. So what do we do here? So we look at the current instruction, which opcode it is. Then we do this thing. So really it's down here in the constants section where we loop over the constants. And what are those actually? It's an array of values. Right, so that means we should be able to do something like this and say constant get value type string of the constant, and then this guy will define up here, and it should get the value, and then we'll say, I keep forgetting how to do this. Let's well, no, it's switch. Yeah, so it's like this. So switch value and value, and then we need to remember all the types. Okay, so it's nil. Then we will, so what's the return type here? It's going to be string. And here we will just return nil. If it is a Boolean, is that the right way to do it? Let's look at the the greater thing. Oh, not that. How about the not operation? Okay, it's just like this. There's just no highlighting. Then we'll write Boolean. And if it is F64, then we will write number. If it's object, then we will write, for now we'll just write object, but probably we'll do something a little bit more fancy later. So let's now try to run this, and of course it does not work, it never works. What am I doing here? I should write return. And I'm just gonna put unknown. Now I cannot really be bothered with this right now. It's just like a small thing. Yeah, so strings will be reported as objects, but that's fine. And this is a number, and this is a, well, that's not stored as a as a value, which is a bit weird actually. Something just got weird, so let me restart it. So what do we do here actually? Okay, yeah, so true, things like that. It's not values, it's not constant per se, but they just get pushed onto the stack when we encounter that operation, which is fine. Now I think we have so many mains here. So in the REPL, when we print the result, so it's in here maybe, it's inside a run, yeah. So that will at the end it will print the value on the stack. But now I want to do something. So let's say string value and OK is equal to value as string. And if it's OK, then I don't want to print this. I actually want to print this. I want to put it in quotes. And otherwise we just print it as normal. Let's see if that works. Right, so actually we have to say if it's an object and then if it's a string, then we're gonna do it this way instead, so we don't have so much repeated stuff. Get away from here. Like that. Now it doesn't print it correctly because I don't know how to format things anymore in Odin. It's not like that. Oh my god. So we go here. Okay, so it's format print F, and then we need to remember to insert a new line, run this thing again, 1, 2, 3, and then it prints it like this, but 1, 2, 3 is printed like that. So perhaps because we have this decimal points, then it doesn't really matter, but at least now there's no confusion about what's a string and what's a number. That's what I wanted to achieve. Okay, I just realized the problem, which is that Odin strings are apparently immutable. So we cannot assign to strings, we cannot do anything. So that means that every time we were to do something, we would basically have to copy the string. I want to try to avoid that. So let's go in here and change the implementation of this thing to our own string type. So we're indeed going to make a struct that has a length and a data field. And then we should indeed be able to do something like this. Now it's not going to compile because these are all very weird things. So we're going to say, did I not save or something? No, this one shouldn't be there, so okay. So let's go back into the compiler and compile string. So now we have the legacy, and really what I want is, let's call it the contents, is going to be this thing, and then the string object is going to be of course of the type object, and well, no, it's not going to be this, it's going to be the type string. So we're going to need a length, which is, suppose it's just the length of contents, and then can we do something like this? Now this is supposedly a string, so I guess we have to cast this to an array of U8s. And then here we don't need to cast this anymore, we can just pass it like that. And let's just keep Copilot on, why not? So we have some syntax errors around here. Do I have to do this? Something like that. I maybe we should have written all this in C anyway, because I'm not very good at Odin. So we had something like this. Okay, so we don't need these, but this should be that. Okay. Array count must be a constant integer. Got U8. Can I do this? So it's a dynamic array. And yeah, here we have a problem. This should be VM string. We don't really need this anymore. And let's make this guy an int instead. And I don't know why I didn't see this. It should be called data. Okay, so we cannot cast, I'm not looking at this one, we cannot cast a string to an array of U8s, but I'm sure there is some way. If we look here in the function definitions in the string, so let's say bytes, we want the bytes basically. That is somehow not possible. Maybe we can just do this. No, that's too much to hope for. Maybe we can cast it to a C string first. No, we cannot. Okay, so maybe we'll have to do this. That's a little bit annoying, but let's say string bytes, it's gonna be an array of U8s. We'll make that, and then we'll say for byte val, and we don't need the index, so maybe I just do like this. In contents, we just say, no, maybe I don't need the index, so let's keep the index, and let's say the index is equal to that byte value, and here we just put in those bytes. Let's see if that compiles. So that did not compile. Now we have this casting error. We also have something here interesting. Okay, so it's also not like this. These are the runes. And then we have to say contents index. Now we have the bytes, I hope. Yeah. So now we just have this casting error. Right. So first we have to make it into cast it as an object, and then okay. Now we just have this comparison thing, which is a problem. So I suppose that's in run equal. Okay. So can we do this? That Copilot suggests. Who knows? So if they're both objects, then we need to do another thing. We have to do another switch. Like that. This we can remove. Guess I'll return false here. And let's see if that compiles. It does not compile. So first we have to switch on. That's. You have to say value A in A. And then if that is an object, then we'll say switch. We'll say object B is B as an object, and if okay, then we have to get the strings out. So let's say string A. Okay, A is that as a string, string B, okay, B. And here I suppose we actually need to implement something like string equal. And if they're not both strings, then we return false for now. Or actually, let's do this and we'll say that we can compare them. Okay, so if A is an object and B is not, then we will do the same thing here. And finally in the default we'll say just do that we did before. And yes, it is a partial switch. That's very annoying. But okay, so we'll let Copilot do most of the work. I cannot be bothered. I think we're good. We are not good. And this should be object B. This should not be value A. It should be value A. A little bit confusing, but that's how it is. So let's implement the string equal thing, which I'm going to implement in here. Should return a boolean, and we'll say if the links are not the same, we return false. If any elements are not the same, we return false. Otherwise, we return true. And we have to do this. And we have to fix some kind of bracket here. Not sure which one it's matching. Let's see. This one matches here, but then this one matches here. So that should be fine. It's saying missing return statements. So I guess here we will just return false. Maybe we should really throw an exception or something, but whatever. So, is 1, 2, 3 equal to 1, 2, 3? That didn't work because I made some kind of elementary mistake here. That evaluates to true. Is 1, 2, 3 equal to 1, 2, 4? That is false. So that seems to be working. I think we'll leave it off here for now. Now we have mutable strings implemented in our little programming language. And strings are, believe it or not equal to numbers and so on. Okay, I will see you in the next one.